Hi, and welcome to this tutorial. Today we want to show how to use and what is a servomotor. Also, you're going to learn how to make a program in the Arduino interface. But, what's a servomotor?
The servomotor is an electric motor, reducing gears and control car all inside of a plastic housing. This motor has the ability to be controlled both in their speed and the position. Since 0 degrees to 180 degrees range, but also exceeds some motors that could be positioned in 360 degrees range.
Servomotors are small and efficient, but critical for use in applications requiring precise position control. The servomotor is called by signal data, better known as pulse width modular PWM. Here are several of the most common servomotor applications in use nowadays, like robotics, cover belts, robotic vehicles, solar tracking systems, and textile.
The world will be a much different place without servomotors, whether they are used in industrial manufacturing or in commercial applications. Also, they make our lives better, easier, and sometimes provide us more affordable products.
But how a servomotor works? Well, the servomotor works by means of the pulse-wide modulation. All the servomotors have three different cables. The first one is red and it's always for direct voltage. The second one is the ground, and the last one, and the most important, is the cable that sends the signal. The uses frequency to send the pulse sequence to the servomotor is of 50 Hz. That means that each cycle lasts 20 milliseconds. The duration of each pulse can be interpreted like most of the position commands for the motor, while the space between each pulse are defined. The necessity of a control signal for the functioning of this motor turns it possible to use a control circuit. This because it's necessary a modulated control signal, in this case a PWM. Here you can see the block diagram for servomotors. Here we have the PWM signal that go to the control circuit that send a signal for the servomotor, and these signals pass for a potentiometer that helps with a feedback again to the circuit. The servomotor has inside a DC motor that helps us with the mobility of the servomotor. Also has the reducing gears and the displacement sensor. The first one helps us with reduce the speed of the motors in order to increase the torque, and the second one is used to know the position of the servomotors. The most of the time is used as potentiometer for this. And in the end has the control circuit, that is the electronic board that implement the position control steering for the feedback.
The materials we need are one Arduino, one servomotor, two push buttons, 10 jumpers, 2 LEDs, 2 resistors, one computer, and the most important, a breadboard.
We are going to start with the connection in the circuit. In the port with 5 voltage, we are going to connect the cable with the breadboard in the positive side, and the second step is to connect the ground. You can use wherever of these sides. We use this blue cable to connect with the negative side or ground in the breadboard. Then on the pin number 5 on the Arduino, we connect with the help of a jumper the signal. This one cable, the yellow one, and that is going to send us the pulse, and it is connected in this side and the servomotor. So we connect the red wire, this one in the middle of the servomotor, to the servo with the connection in the breadboard. It is in the positive side, and the brown wire we are going to connect to the other side, in the negative side, on the breadboard. That is going to be the negative or ground. The next step for connect the buttons, first with the help of a jumper or cable, we connect one side to negative ground, as you can see, and this side we connect one pin with on the buttons, and the other side we are going to connect with the LED and a resistor to the positive side, that are these one red cables. And finally we connect the left button on pin number 3 on the Arduino, and the right one are going to be connected on the pin number 2, and you can see the function of the circuit. In this way it is in a height, and when we press any one of the buttons, the low will be activated, with which the servomotor will turn according you wish.
The following part is our program. The first step is to include the servo library, and the second step is we create the servo object to control the servo. That is this part. Following, we pin up the right button in 0, and also we pin up the left button in 0. We attach the servo on pin 5 to define the minimum and maximum of white poles. We set up the pin up 2 such as an input, and also we set up the pin 3 such as input. In this part, the program reads the value of the pin 2, and if it is in high or low, value between 0 and 123. In this part, the program reads the value of the pin 2. In this part, the program reads the value of the pin 3, and if it is in high or low. And in this part, if I push the right button, the servo rotates 180 degrees. And to do this action, we put a delay to give it time to arrive at the position. And in this part, if I push the left button to the servo rotates minus 180 degrees to arrive at the position 0. And we also put a delay to give it time to arrive at the position, exactly 15 milliseconds. And this is a restriction. If both buttons are not pushed, the servo rotates to 90 degrees position, that is the main position of our steering wheel. And to do this action, we put a delay to give it time to arrive at the position, exactly 15 milliseconds.